Hi everyone. If you're watching this video, this is actually a remake of an original that actually I did incorrectly. So thanks to my online student, Michael, who figured this out. Props to him. Let's do this right now. And also my apologies to my aviation students if you're one of my aviation students watching this video. Um, I'm trying, okay? This is going to be an idealized case. I'm guessing those of you in aviation have a lot more know-how about a lot of this stuff, working with airspeeds and such, but this is going to be an idealized case. Now, this is a problem that I created. I'm kind of proud of it, and since this is my word problem, I'm going to do it the way I want to, doggone it. So I, Ben, traveled to New York City on Delta Airlines. I'm going to leave from Salt Lake International Airport. I'm going to land at JFK International. Since it's my problem, I'm going to travel first class. I'm going to sit next to Jennifer Aniston and Jennifer Lopez across the aisle. Yeah, I'm going to be in heaven. But despite all that, the math guy in me is going to do number crunching despite the distractions that I'll have on either side of me. The duration of this flight with the wind is going to be 4 hours and 18 minutes. That's 258 minutes total. I'm going to convert this into minutes instead of hours and minutes. It'll be easier for calculation. And it's going to be for a total distance of 1,986 miles. On the way back, I'm going to stop at the Minneapolis Mall of America and I'm going to buy some gifts for the Jennifers. So I'm going to leave JFK, land in Minneapolis International. This journey, it's going to be 2 hours and 43 minutes, which is 163 minutes total, for a total distance of 1,027 miles. So again, assuming no change of wind speed, both journeys, assuming the same plane for both trips. So, we're totally idealizing this a little bit, but it'll help us with the calculations. Now, when you're doing a word problem involving uniform motion like this, and there's a current speed like with a river or a stream or something like that, or if you've got an airspeed like we've got here, what you're going to want to do is set it up like this. This would be my recommendation anyway. There's two ways to do this that I can think of. There's probably more, but two pop to mind. One common way that you see in a lot of textbooks is this. They'll set up this little chart here, rate times time equals distance, right? That's the uniform motion equation there. And we're going to be comparing with the wind and against the wind. I'm going to let x be the speed of the plane in still air and let y equal the airspeed, okay? So right away, I'm going to go x plus y. Oh, really? You're doing this to me? There. Try to keep it lowercase. And let's go x minus y. Okay, and those are going to represent with the wind and against the wind. So with the wind, I mean, it makes sense, right? The speed of the plane, and then you're going to go even faster because the wind's pushing against you. That's why it's ax plus y here. And then if you go against the wind, for those that travel a lot, you know this, you're going to have the speed of your airplane, but then you're getting slowed down by the speed of the air. That's why it's x minus y. All right, well, what do we know? We know the time going with the wind, and I'm going to do this in terms of minutes. Let's go 258 minutes. And I know that corresponding distance is going to be 1,986 miles. Against the wind, I know that it's going to be 163 minutes. And I know that it's going to be 1,027 miles. All right, now we're looking at rate times time equals distance, right? So pardon me for those that are all anal about making sure I use italics for variables and all that. I'm not going to do that here. I'm just going to put this in a Word document and just crank this out, okay? So rate times time equals distance. So we're going to go 258 times the x plus y, and that's going to equal 1,986. Okay? Rate times time equals distance. So that's one equation. And the other equation, I'm going to set that up similarly. I'm going to go 163 times the quantity of x minus y equals 1,027. So those are the two equations I'm going to solve. Now, a hint here, to set this up, I could distribute the 258 through the first equation, and I could distribute the 163 through on the next equation. Because I'm going to get decimal answers. I'm going to be rounding these to the nearest tenth. What I'm going to do is I'm going to divide both sides of the first equation by 258. Okay? What that does is it's going to give me just the x plus y, and 1,986 divided by 258 is going to be 7.7. Now let's do something similar with the x minus y. If we divide both sides by 163, 1,027 divided by 163 is going to be about 6.3 when you round it to the nearest tenth. Okay, so take a look at that. I've got two equations with two unknowns. I can go ahead and solve this thing now. If I just use the elimination, some of you might know it as the addition method. If I add these two equations as they are, the y values are just going to drop out, and x plus x will not equal x. It's going to be 2x, right? Think of it this way. You got a 1x up here and a 1x right here. 1x and 1x is 2x, all right? And that is going to equal 14.0 if you really want the decimal there, right? That's what 7.7 plus 6.3 is. 14 divided by 2 will tell you that x is going to equal 7, and that's going to be miles per minute. All right, now I'm probably going to want my answer in miles per hour. I mean, that's what people typically think of. So what we can do is we can do 7 miles per minute, and if we multiply that by 60 minutes per 1 hour, basically what that means is you're just going to go 7 times 60, which is 420. And by the way, that's where I screwed up in the original video. Sorry about that. I think I left it at 130 for some reason. I'm not sure why. Okay, 7 times 60, 420. And now my units, if you're going to be in chemistry, you're going to need to know this. But here I have minutes in the denominator. Here I got minutes in the numerator. These units are going to drop out. So I'm going to have miles per hour. So 420 miles per hour, which makes a little more sense, you know. That's, you know, typical of these Boeing 747s, 727s, something like that. That, from what I understand, they go about in speeds like this. Those of you in aviation are definitely more authorities on something like this than I am. All right, let's go find out the airspeed. Okay, we need to find y. Well, I can use this equation. X plus y equals 7.7, right? Recognize that? That's this guy up here. Well, I know what x is. It's 7. Okay, I'm going to use the 7, not the 420. Not right now. So I'll plug in 7 for x, and I'll solve for y. You guys probably already know what that's going to be. Y is going to equal 0.7. Again, it's miles per minute. But then we want to take our 0.7 miles per minute, and we're going to multiply that by 60 minutes per 1 hour. And what that'll tell us is we're taking 0.7 times 60. It's 42, excuse me, 42 miles per hour. So that is going to be the airspeed. And again, our airplane speed in still air is 420 miles per hour. Okay, so those are the answers for this problem. But you know what? Real quick, let me show you a shortcut on these kinds of problems. Probably don't want to do that in bold, but it's going to kind of make this video a little long. My apologies. But what you can do is when you see this original problem, okay, you take your original problem, and if you just take your 1986 and you divide that by 258, you're going to get, what did we get when we did that? 7.7. Okay, and then let's take the 1027 divided by the 163. And that's going to give us the 6.3, right? Now average the 7.7 and 6.3. So here we go. 7.7 plus 6.3, and then divide all that by 2, right? Guess what you get? Boom! 7. What? Really? Yes, really. That's your 7 miles per minute. And then from there, you do your calculations to get into 420 miles per hour. So you can do the shortcut on these kinds of problems, is what I'm saying. When you see these problems, this is when you're looking for the speed of the plane in still air and the airspeed. Okay, if those are the two unknowns, you can do the sort of a shortcut every time, if they give you the distances and the times. So you take the distance of one, divide it by its respective time. Take the distance of the other one, divide that by its respective time. Once that's found, take the average of those. Okay? As for the air, check this out. How about this? I'm going to do this. I'm going to go 7.7 minus 6.3. Divide that by 2. Guess what I'm going to get? Boom! 0.7 miles per minute. That's your air. What? Yeah, it's really cool, huh? So that's a pretty cool little shortcut you can use if you're so inclined to take a look at that. All right, this video's gone plenty long enough. I hope that helps. Thanks for watching.